Hello pre-calculus kids. Today I'm going to try to show you some more examples of how to graph sine and cosine functions. You will need your reference sheet that we created in our last video, and you will need your note packet or just paper. You can write these down on paper too. They're going to get more complicated as they go. So we know that that's usually the case with math, right? They start out with something really easy peasy and then they get into like crazy stuff. So we're going to kind of build towards that. When we were together last, I gave you this basic function, 3 cosine of x. We graphed that one together. And now we're going to try some that have numbers in more than one place. So instead of it just being the height that's different, this one's going to have the height that's different, and it's going to also have a period change. It's going to be a little bit wider or shorter than what it normally would be. That number in front here makes the width of the wave different. All right, so let me show you how it works. Same with the reference sheet, same stuff that we were doing before. We're starting out with the period of the graph. The period of the graph is 2 pi divided by b. b is the number in this place right here in the front of the x, so 6. If I reduce that, now I have pi over 3. If I look at the amplitude is the absolute value of the number in front. And so the number in front is a 2. If I take the absolute value of 2, it's 2. Now, in order to figure out the left, the center, and the right, now I have to look at this piece here. Now, there is not, if I remember when I showed you these before, you had an A, you had a, oh, in this case it's a sine. You have a sine. And then we said this, we said bx plus or minus c plus or minus d. If it has parentheses, you take this whole set of parentheses and set it equal to your left, your center, and your right. This one doesn't, it just has a 6x. So this 6x is what you're going to take and set equal to your left, your center, and your right. So I have a 6x equals, when I go to my reference sheet for the sine, the left gets set equal to negative 2 pi, the center gets set equal to 0, and the right gets set equal to positive 2 pi. So 6x equals negative 2 pi, 6x equals 0, and 6x equals a positive 2 pi. Then you need to solve for x. So if I have 6x, I want x, I don't want 6x. So I'm going to divide both sides by 6. They cancel here. X equals negative 2 over 6 is pi over 3. If I come over here, 6, divide these guys by 6's, I get x equals 0. And on the right, it's going to be the same work I did here, it's just as positive. So divide by 6, I get x is pi over 3. And then you have enough information to be able to set up your graph. And so on the left, you put negative pi over 3. At the center, you put 0. By the way, this is not always going to be 0. It is for this problem and it was for the last one, but you can't just automatically assume that that's a 0 place. It's just whatever the center is. You'll see as examples go. This one is pi over 3. My amplitude is 2. That means this is 2. This is negative 2. I need 4 dashes on either side. And then what I need to do is figure out how I'm going to dot this thing. So I go to my reference sheet. I look at the sine. Sine on my reference sheet starts right here at the center. And then the next dot goes up, and then back to the x-axis, and then down below, and then back to the x-axis. So we're going to dot the dots exactly like our reference card says. And so for sine function, starts here, goes up, back to this x-axis, then down, and then back. And so here's my curve. Same thing over here. Continue the wave. Dot it exactly like your card. And there you go. You have just graphed a 2 sine of 6x. Next one. Next one is this guy here. And this one again adds in a whole nother thing, right? We've got a whole nother situation in here that we haven't seen before. And that situation is, let me find a different marker here, is this negative sign. Do you remember what negative signs do to graphs from back when we were doing translations? And hopefully you should remember that that negative flips this graph. So there's going to be a flip and it's a flip over the x-axis. We're not going to worry about that though until we get to the end and get ready to graph this thing. So it's just something that we're going to kind of put on hold for now, but realize that that's going to come into play when I go to put my dots on the paper. All right, otherwise for this one we're going to continue on and do the same stuff we've been doing with the others. So I'm going to take the period. The period is 2 pi divided by b. Well, holy moly, that's a big B, because if I take what's in front of the x, it's the 60 pi. So I'm going to take 60 pi is my b, whatever's attached to the x, whatever's in front of it. And when I look at this, well, geez, my pi's cancel. I have 20 over 60, so I really have 1 over 30. Well, that's kind of a weird looking period because normally they have pi's in them and this one doesn't, and that's okay. It's just the way that this one went. The amplitude is the absolute value of A. A is 1/10, which is negative 1/10 actually. Absolute value of that is a positive 1/10. So now I have the period and now I have the amplitude, and let's go for the left, center, right. According to my reference sheet for cosine, the left gets set equal to negative 2 pi, the center to 0, the right to 2 pi, and that's what I'm going to do. So my left is, now you have to take this whole thing, we saw this in the last problem, the whole thing after the cosine, 60 pi x gets set equal to negative 2 pi, 60 pi x gets set equal to 0 at the center, and 60 pi x gets set equal to positive 2 pi on the right. And then I'm going to solve for x. If I want the x by itself and it's attached with this 60 pi, then I need to divide by that to get rid of it. So I'm going to divide this side by 60 pi, this side by 60 pi. Well, geez, that kind of looks familiar, right? Back in the period, my pi's cancel. I have negative 2 over 60. Well, that's the same thing as negative 1 over 30. If I go to the center and do the same thing, divide by 60 pi. Bye-bye, 60 pi. I end up with x equals 0. And on the right, again, dividing by 60 pi, can you see the similarities between these, right? If I divide by 60 pi, I get an x is 1/30. All right, all my pieces are there, my 5 pieces. Here I go. Left, negative 1/30. Center's at 0. Right is at 1/30. The height is 1/10. Lowest is negative 1/10. 4 dashes on either side. And here I am ready to go. So I'm looking at the cosine graph. I go to my reference sheet. Here's my reference sheet. My first dot at the center, I always start these at the center. You can really do it any way you want, but if I start at the center, it would be at 1. All right, but there's a problem with this one. Do you remember the green guy over here? Mr. Green Guy said, all right, we need to flip it. So normally my first dot would be up here. If that gets flipped over, if it gets swung around the x-axis, instead of it being a top point, it's going to be down here. Anybody that was, now my next point would have been right here on the x-axis. That still is, it still revolves around that x-axis. So this particular one is still going to be on the x-axis. And then the next one, instead of it being, it would have been a low point, it's now a high point. Then back to the x-axis, and then to the bottom. So you can see it's directly the opposite. Your tallest points and your bottommost points are the ones that change location. So your toppy tops go to the bottom, and your bottomy bottoms go to the top. And so you're going to create your wave off of that. Looks like this now. If I continue on over here, same idea. Here's my wave. And you can see, if I were to compare this with what the reference sheet is, this one is like a hill in the middle. This one's going to be a valley in the middle because they've flipped over the x-axis, and that's what you got going on. So there's one with a flip. Here comes the next one. We got 2 to go for the day today. All right, here's the next one. I'm going to start with the same stuff. I want to, looking at this, I don't have a negative, so I don't have something to put on hold. You're going to see later that we're going to have up and down movements. We don't have that either. But we do have an extra special. This is the first one with parentheses. It's going to get a little bit challenging when I go to find the left, center, and rights. But I'm going to show you a trick that will hopefully make your life a little bit easier. All right, so here goes. Period. Period is 2 pi divided by b. Now b's a little tricky in this case because see, b would be the coefficient on the x, and there really is just a 1 in front of there, but there's this crazy 2 that's in the denominator. And so what I really have in this case, if I have x over 2, that's the same thing as 1/2 x. Because the 2 has to have a denominator, it has to be in the denominator. So 2 pi divided by b, 1/2, makes me have to go horizontal. We saw that the other day in some of the problems that we did. So 2 pi divided by 1/2, keep change flip, 2 pi times 2 over 1 gives me a 4 pi as my period. The amplitude is the absolute value of what's in front. The absolute value of 2/3 is 2/3. All right, here's where it gets a little tricky. Left, center, right. I'm with the cosine graph. Cosine graph says, here's my reference sheet, cosine graph says the left gets set equal to negative 2 pi, center to 0, right to positive 2 pi. Here I go. I'm taking the entire set of parentheses this time. X over 2 minus pi over 4 equals a negative 2 pi. And here's your job. Your JOB is to figure out what x is. Solve for x. And you say, well, geez, there's a whole lot of stuff going on there, Winner. I'm not quite sure with all these fractions freaking me out how to do that. And so what you're going to do is you're going to take the biggest denominator you got, which is a 4. And what you're going to do is you're going to multiply everybody by 4. I'm going to put the little trick over here, what we're going to do. Multiply by 4. In other words, 4 over 1. That's the trick we're going to use. Because what that's going to do is get rid of all the fractions and make it way easier for me to be able to calculate out what this is going to be. So, here we go. And by the way, this is a legal math move because as long as I do it to each piece, it keeps an equivalent form of that equation that you started out with. So it's a legal math move. The math police are not going to come and take you away. All right, 4 over 1 times x over 2. 4x over 2 gives me 2x. And I'm like, cool, no more fraction. Minus pi over 4 times 4 over 1. 4 over 1, 4's cancel, and I'm left with a pi. 4 over 1 times negative 2 pi gives me a negative 8 pi. And there you have it. Now you can solve for x way easier because you can see you add pi on to the other side, so 2x. If I'm at negative 8 pi and I add a pi on, I'm at negative 7 pi. And then to get the x by itself, I just have to divide by 2. And so x equals negative 7 pi over 2. All right, here comes the center. Hopefully that's a little easier because that's set equal to 0. I have pi of x over 2 minus pi over 4 equals 0. Well, I still don't like this very much. I can use this same rule to multiply by 4. There's a couple things I could do. I could swing this to the other side and cross multiply. Lots of different math moves you could make. But I'm going to go with this multiply by 4 deal because you already did the work right here. If I multiply x over 2 by 4, I get 2x. If I multiply pi over 4 by 4, I end up with minus pi. 0 times 4 is 0. And so then I can swing the pi to the other side. 2x equals pi. It becomes positive over there. Divide by 2. X equals pi over 2. And then when I go to the right, I can still do the same type of thing. X over 2 minus pi over 4 equals positive 2 pi. And the work's going to be the same work that you did initially over here, except this is going to be a positive 8 pi. So 4 times x over 2 is 2x. 4 times pi over 4 is pi. 4 times 2 pi is 8 pi. Now when I add the pi on, now I've got 9 pi's over here. So I've got 2x equals 9 pi's. Divide by 2. Woo! There it is. You are done the hard work. Now it's just a matter of graphing it. So my left is negative 7 pi over 2. My center is no longer 0. Check it out. It moved. This center line is going to now be called pi over 2. This guy on the right, he's a 9 pi over 2. My amplitude is 2/3. This is 2/3. This is a negative 2/3. Split it into 4 sections. 4 sections. And then I go to my lovely reference sheet. I'm looking at the cosine graph. I got to figure out, how is this thing dotted? It's not flipped. I don't have anything else going on with it, so it is dotting at the center is my top point. Top point center. Here it is, top point center. Then it goes to the axis and then down to the bottom, to the axis, back up again. Same dots over here. Connect your dots. Just connecting my dots. I got a pretty smooth wave. And there you go. Now you have a graph for 2/3 the cosine of x over 2 minus pi over 4. All right, 1 to go. Here's our last one for the day for this particular video. It's this one, and this one has something a little different too. Here's the thing that's going to be on hold this time. This is an equal sign, by the way. It doesn't quite look like an equal sign, but it is an equal sign. Here's the thing you got on hold this time. This is a +1. And what that thing at the end is going to do for you is move it up or down. We talked about that in the previous video. In this case, it's going to move it up 1. But that doesn't come into play until you start graphing it. So that's kind of on hold, like the negative sign we put on hold on that one a few minutes ago. All right, so here's this one. Let's do our period and amplitude. Period is 2 pi divided by what's in front of the x? Well, in front of the x is 2 pi. Well, that's kind of cool, right? 2 pi over 2 pi, that's 1. Sweet. No pi's. Amplitude is the absolute value of the number in front. Well, there is no number in front, so there's an invisible 1. There's another 1. And so far you're looking at this going, that looks really complicated, but this looks really easy. Let's see if that continues. And it doesn't, right? So here I go with my left. Whatever's inside the parentheses is what you put on the left here. So you're going to have 2 pi x minus pi over 2. On the left, go to your reference sheet. It's set equal to negative 2 pi. At the center, 2 pi x minus pi over 2 gets set equal to 0. And if it's on the right, 2 pi x minus pi over 2 gets set equal to positive 2 pi. And now here comes the hard work, right? I need to solve for x. So I showed you the trick on the last one. You take whatever the biggest denominator is, and you multiply everybody by it. So in this case, we're multiplying everybody by 2. Technically 2 over 1. So here's what you're going to get. 2 times 2 pi x is 4 pi x. 2 times pi over 2, 2's cancel, is pi. Negative 2 pi times 2 is negative 4 pi, and now you're able to solve for x. So you're going to swing this pi over, you're going to add a pi to negative 4. 4 pi x equals negative 3 pi. Divide by 4 pi because you want the x by itself. So this side gets divided by 4 pi, this side by 4 pi. Pi's cancel. And I get an x that is a negative 3/4. All right, here comes the next one. Same thing, multiply by 2. You just did the work right here, so you're not recreating the wheel too much. If I take 2 times 2 pi x, I get 4 pi x. 2 times pi over 2, I get pi. 2 times 0 is 0. Swing the pi to the other side. 4 pi x equals pi. Divide by 4 pi. Pi's cancel, 4's on the bottom. X is 1/4. All right, last one. Again, you got 4 pi x minus pi. 2 times 2 pi is 4 pi. This time when I add a pi on, now I'm at 5 pi. So I have 4 pi x equals, because I'm moving the pi over, 5 pi. Divide by 4 pi, and I get 5 over 4. There's the hardest part. You got your 5 pieces. Now it's a matter of making your graph. So here it goes. Leftmost place is negative 3/4. Center's at 1/4. The right is at 5/4. I have an amplitude that's 1. Now I'm not going to put it up at the top too far because guess what? We need to move everybody up 1, so hold on a minute for that. But my amplitude is 1, so I would be 1 and negative 1. I'm just not putting it up as tall as I could put it. 4 dashes in the middle. 4 sections, I mean, you got there. All right, I'm looking at the sine graph. The sine graph, go to your reference sheet. Your sine graph, where do you dot it first? Well, you dot it first here at 0. But if I'm moving it up 1, let's think about this for a minute. My dot would normally have been right here at 0. But if I do 0 plus 1, now it's up here. That's going to be my first dot. So let me take this one away, because that's not where it's going to start. It has to start up 1. The next dot would have been here at 1, but I have to move that up 1. If I'm 1 and I add 1 more to it, now my top point's at 2. So now I'm up here. My next point would have been at 0, but it's up 1. My next point would have been at -1, but it's up 1. My last point would have been at 0, it's here. And so you can see my wave this time starts at 1, goes down, and then back up again. It's the same exact picture you have here, except it's moved up 1. You've got all of your values moved up 1. So if I continue the wave going the other way, it would be coming down to the axis for this guy, then back to the middle, and then to the top, and back to the middle. And so my function would look like that. So there's one that's been moved up 1. So instead of it starting at 0, it's going to start your first point at 1, and then the tall point would have been at 1, it's up at 2, and so forth down the line. So you're taking the same values you have on your reference sheet, but you're adding 1 to it, and that's what your graph's going to look like. All right, so we are going to meet one more time and finish out the rest of these examples, and you can see they get harder as they go. Pretty much you're not going to see a whole lot of different stuff than what I just showed you today, except ones that might flip and move up or down in the same graph. So we're continuing on with more examples next time we get together. Hope you're doing well. You can email me with any questions, and we will talk soon. Bye.